Paper 6 Preparation, Organic Experiments, Cambridge IGCSE Chemistry. We'll start with the fractional distillation of crude oil, then the cracking of larger alkanes, and then the production of ethanol by the anaerobic fermentation of sugars, and how ethanol is separated from the reaction mixture. Fractional distillation is used to separate the mixture of hydrocarbons in crude oil into various parts, which we call fractions, hence fractional distillation. So crude oil is a mixture of hydrocarbons. We use a setup like this. We have mineral wool soaked in crude oil. Of course, we heat that. A couple of practical points to note. The bulb of the thermometer is opposite the side arm, so we're measuring the temperature of the vapors that exit the reaction tube. The way I've got my diagram is that the fractions collected at low temperatures are to the right. You should know that these fractions have low viscosity, that is, they are runny, and they are colourless. As the temperature rises, so that we reach a high temperature, so we've got a high temperature there, so this fraction is collected at a high temperature, this would be thick and have a high viscosity and be much darker in colour. So there's a trend in these properties, colourless through to dark and runny through to highly viscous. A further organic experiment that appears in recent paper 6 is cracking. That is the changing of long chain alkanes into shorter chain alkanes and gaseous alkenes. So we say that the long chain is cracked, broken into parts to give us shorter chain alkanes and gaseous alkenes. The setup we see here, again, mineral wool soaked in the large alkane. We have here a catalyst of small lumps of aluminium oxide. The small lumps are to increase the surface area. So we vaporize the large alkane. It passes through the lumps of catalyst. A reminder that the heat source is called a Bunsen burner. That has appeared as a question in recent paper 6. So the heat is provided, but we need to heat in two places. Firstly, the catalyst, and we also heat the alkane in the mineral wool. And generally you move the Bunsen burner backwards and forwards, so you're heating in two places at once. So we collect a gas by downward displacement of water, and test tubes are collected. So these are the first two test tubes. We generally assume that the first test tube is principally air, expanded air, or air driven out of the apparatus and into this tube here. And the second tube would generally be regarded as containing the gaseous alkene. Now, once you stop heating, you have to take the delivery tube out of the water to avoid what's called suckback. So to avoid suckback, the delivery tube is removed from the water trough. Now, how do we test for an alkene? We take orange bromine water, pour the bromine water into the alkene sample. We get immediate, with a little bit of shaking, we get immediate decolorization. In other words, the bromine water turns colorless. That is the test for alkenes. Anaerobic fermentation of sugars to form ethanol and carbon dioxide. Again, here is the setup. Do you recall the conditions? What are the reactants? What do we mix in here? What sort of temperature do we use? Speak out an answer. Okay, you need to recall that we have sugar solution and yeast. So this is my representation of the yeast. And we need a temperature of around about 35 degrees Celsius. Not higher. If it's too high, 40 or above, the enzymes in yeast are less effective. At a lower temperature, the rate of reaction is too slow. So you are expected to recall that fermentation ideally is at around 35 degrees Celsius. Another question that comes up in paper 6, can you name this piece of apparatus? You're right, it's a conical flask. So we also should note, to maintain the anaerobic conditions, that is, to reduce any or remove the possibility of the flow of oxygen into the conical flask, we have the delivery tube below the level of lime water. So this liquid here is lime water. We leave that for 3 days or so, in which time we will start seeing bubbles. What gas is that? It's bubbles of carbon dioxide. What happens to the lime water? It turns milky white. We've got remaining in the conical flask, if carbon dioxide is escaping, we've got remaining in the conical flask a mixture. That mixture should contain ethanol, but it will also have water and the solids from yeast. So let's start with the mixture of ethanol, water and the solids from the yeast preparation. We want to extract a pure sample of ethanol. Well, the first thing to do is to carry out a filtration to remove those solids and produce a solution of ethanol and water. Common questions in paper 6 is to name the various pieces of apparatus or glassware involved in this process. So can you name this piece of apparatus I am highlighting here? That is a filter funnel, and inside the filter funnel we have what? Filter paper. Also appeared as a question in recent paper 6. The general name for solids collected in the filter paper, of course, are residue. And what is the general name for the solution collected that passes through the filter paper? It's a filtrate, which in this case is a mixture of ethanol and water. So having obtained a mixture of ethanol and water from the process of filtration, we need to set up for fractional distillation of that mixture, which will separate the water and the ethanol on the basis of them having differing boiling points. So here's the experimental setup. What is the name of this piece of apparatus? Okay, it is a condenser. For these water inlets and outlets, which way round is it? Which has water in and which has water out? So water in at the lower inlet and out at the upper. Additionally, notice the position of the bulb of the thermometer opposite the side arm. If we're collecting ethanol, what is a suitable temperature to be recording? Okay, so temperature 80, the reason being it's lower than the boiling point of water, but at a temperature that will keep ethanol as a vapor. So ethanol rises and leaves via the condenser, whereas water may rise, but it will condense as the temperature drops and drop back in. So there is our fractional distillation of the ethanol and water mix, and we will achieve a pure sample of ethanol. Okay, so move on to another paper 6 prep lesson, or try some past papers. If you found this lesson helpful, please recommend to a friend. Thank you.